Section, we're going to spend a lot of time doing different kinds of division. We're going to start off easy with something like this, where I am dividing a polynomial by a monomial. When we have a problem like this, where the divisor is a monomial, what you need to do is split the dividend, the top. Split it all up over 3xy, and we've kind of done this a little bit before, but what you're going to do is split them up into 3 separate fractions all over the same divisor. Okay? Go ahead and finish this problem. All right, who's got an answer? Natalie, what do you got? Very good. How many had that? Good. Okay, so this is going to be the basis of some long division that we're going to do. Okay? All right, so first thing we're going to look at is synthetic division. Anybody seen synthetic division before? Okay, good. There's going to be, in the video, I put the link if you want to watch it. There's not going to be sound for this because I can't connect my iPad to anything in here. All right, but he's going to go through this problem, then we're going to go through a problem, and I'm going to narrate it for him. For you, okay? Essentially what synthetic division is when you have a binomial divisor. Okay, that last problem, the divisor was a monomial. So whenever I have a binomial, synthetic division is a trick. It's a trick that works, and we're going to use it. And we're going to rely on the coefficients in order to do this. Now,
do an example of what's called synthetic division. Synthetic division is when you basically are dividing one polynomial by a first-degree polynomial. So
divisor,
x to the first.
What you're going to do
it may or may not have
you're going to use the
a number in there.
If
it's just x, you would just break things up individually, and it'd be pretty easy anyway.
And then we're going to use this too.
So suppose we want to divide again x cubed minus 2x squared plus 3x minus 4. We're going to divide that by x minus 2.
And he's going to draw a line that I'm going to have actually flipped over, and eventually he flips it over. But he starts off drawing it like it's a regular long division problem, which it is not.
So notice there's a minus 2,
it's
x minus 2. We actually take the opposite sign, and we'll use positive 2, and that's what you stick outside.
So when we take the number outside for the divisor, we actually take the opposite of minus 2. Now, notice
there's
here,
no
he
terms
put
missing.
the coefficient for the x to the third term in, because we're going to need that 1. I'm going to show you a problem in a second, because this one goes x to the third, x squared, x, 0. It doesn't skip any of the powers. I'm going to show you a problem in a second where we skip a power, and in that case, we're going to have to insert a 0. And I'll show you how to do that. But because this one doesn't skip, we're just going to be able to copy those
second degree, first degree, and then we just have a number.
Right down next
All we do is we write the coefficients. So 1, there's a negative 2 in front of the x squared. There's a positive 3 in front of the x. And there's a negative 4.
And so what's going to happen is our setup is really important. Making sure that we have the right number outside from the divisor, opposite sign, and then all the coefficients. There will always be one more term inside here than the highest power. It's because of the coefficient. Because this is an x to the third, there's going to be 4 terms, because I got an x to the third term, an x squared term, and x. There's my 3. And then I have one without a variable at all. And so every time in the dividend for synthetic division, you should have one more term than the highest power. Okay? Even if there's not a constant term, you're going to have a 0 as your last term. All right, so let him finish it, and I'll show you what happens next.
And with synthetic division, what you do
is going to be the same.
The first term, you just drop it right down. There's nothing to do.
So the first move is to bring that first number down, whatever it is. Whatever this first number is, you just bring it down. Okay?
Idea is we multiply.
And now he's going to draw some little dots.
So I'm going to take
positive
2
okay, you take the
times
2
1
times
and then stick that number
and
in the next spot.
Right up there.
So it says positive 2 times 1 will give us positive 2.
And then
what we do is we add those numbers together
so
in this column.
-2
so
and
negative
+2,
2 plus 2 is going to give me 0.
Now you do the process all over again.
Now we take
okay,
positive
2 times 0,
multiply it by 0,
take that number,
and that's
put
what
it
we
up
stick
here,
in the next column.
Combine the numbers,
Since it's
and you just kind of
2
keep
times
going.
0 is just going to give us
okay?
0.
So
if we
3
add
and 0,
those
that
together,
combines
we'll
to give me a
get
3.
positive 3.
And now we start
and
all
then again,
over.
I take positive 2
times 3,
times
what's that?
positive 3. Let me erase my little red dots
you're
here.
Combining them.
We'll take positive 2 times positive 3.
Well,
That'll give me
like
positive
in this case,
6.
you're combining negative
we
4
add
and 6.
the columns together, so and we get the number 2.
The next part, last number. The last number is always the remainder. Okay, that's always going to be the remainder, the last number. If it's a 0, that means it goes in evenly, divides evenly. Most of the time, it's not going to be a 0. All right, so this ends up being the remainder. These are the coefficients to the terms, and it's always going to be 1 less. It's always going to be 1 less, because think about it. I'm doing x to the third divided by x. So this coefficient is going to go with x squared. And I'll play it out, and you'll see how it kind of goes. Okay? Again, it's all just a trick. We're going to do regular long division here in a minute. Now, he's going to turn it into a polynomial. And so this x, so those terms that he's putting a box around, those are the coefficients for the x squared, x, and the constant term. So this ends up being 1 less than the x to the third. So this is 1x squared plus 0x, which we don't need the 0x, so it's just 0, and then plus 3 is a constant. Okay, and he's writing all those in so you can see it. Okay, and then we're just going to turn that back into a polynomial. All right. So that's 1x squared plus 0x, but then we don't need it, so he erases it because it's just 0, and then plus 3, and then the remainder, we write it over the divisor. So it's plus 2 over x minus 2, and that's my final answer, okay? Yes.
Isn't this technically
Another problem, okay? So, in this situation, one of the things that's going on is, if you notice here, there's no a to the third term. I can't just leave that out. I have to put an a to the third term, and the coefficient of that is a 0. Because it's not there, it doesn't exist. We don't have to write it. So, instead, what am I going to write out here? Minus 2. Remember, opposite of the divisor, since it says plus 2, so I'm going to put a minus 2. Now, when I put the coefficients in, I have a 4. I can't skip the a to the third, so I'm going to have to put a 0 in. Then a 2, a negative 4, and a 12. Again, like I said at the beginning, you should have one more term than the highest power. The highest power is 4. I have 5 terms. That should always be like that. There's lots of ways that you can do little checks along the way. Okay? What's my next move? Nope.
you drag the 4 down?
Drag the 4 down. Okay? That the first thing, once you're set up, the first thing you do is bring that first number down every time. Now we multiply, combine, multiply, combine, multiply, combine until you run out of numbers. So what's going to go right here? Negative 8. Negative 2 times 4.
The next one is negative 14.
Not yet. We're not there yet. Okay, what do I do with these two? Because that's how you do it. So right, 0, negative 8 combined together gives me negative 8. Go ahead and try and finish it. So my next move is to multiply. Negative 2 times negative 8, that is positive 16. Combine those, what do I get down here? 18. So now I do it all over again. Negative 2 times 18, what's that? Negative 36. Combine those, what do I get? Negative 40. Multiply again. Again, this is the remainder. 92 is the remainder. The last term is always the remainder. You have to have one more than the highest power, and if it skips a power, you got to plug a 0 in there. Now, this is the remainder. So these coefficients correspond to the solution. The quotient, the answer to a division problem. Okay? You got to go down from the highest power. So this 4 goes with a to the third because it's 1 down from the 4th. Okay, then this goes a to the third, a to the second, a. This is the constant, which makes that the remainder. This coefficient always corresponds with one tick down from the highest power. So this ends up becoming a to the third, negative 8a squared, plus 18a minus 40. The remainder gets written over the divisor. And that's my final answer. Yes, because I'm dividing it by a. It has to go down. It doesn't go away, it gets divided. Let's look at long division. Okay, do this problem longhand. No calculator, do it out. The reason we are doing this problem is to remind you all the steps in long division, because polynomial long division is essentially the same thing. There are some different nuances to it, okay, but the algorithm, the process is basically the same. So the first move is to figure out how many times 12 goes into 28. How many times does it? 2. So then what do I do? Well, where's 24 come from? 2 times 12. So I have to multiply, then subtract. Then I do this process all over again. I bring the 3 down. 12 goes into 43 3 times. Multiply 3 times 12. That's 36. Subtract. Bring the 2 down. 12 goes into 72 6 times. Multiply. There is no remainder. It goes in evenly. That's long division. How many had that correct? Very good. You remember how to do long division. Let me show you how it works with polynomials. The idea is seeing how many times the divisor goes into part of the dividend. Then multiply, then subtract. That process gets repeated every time, even with polynomial. Okay, so in a problem like this, you write it out the same way. Now, just like in synthetic division, if there were missing terms in here because it skipped a power, you'd have to put a 0 in. Okay? You always have to put a 0 in. Okay, this one is not missing anything, so it's no big deal. Now, here's where it gets a little bit different. The only thing we do is we check the front of the divisor into the first term. So that whole how many times does x go into x squared? In reality, what that is this. You're doing division. X squared divided by x. What is that? X. So that x goes above the x squared. Okay? Then, once we figure out what number goes up there, what do we do next? Multiply. So in reality, now I'm taking x times x minus 3. Okay? And you have to multiply it out using distribution. Because I have a binomial here, this becomes x squared minus 3x. After you multiply, what do? Subtract. Now, understand what that means. We're subtracting the whole thing, which essentially does what to x squared minus 3x? Changes the signs. Okay, so what I could really do, if you wanted to, and I would suggest doing this, is once you do your multiplication, just change the signs. Okay, now, the x squared should cancel, which they do. That front term, whatever it is, should always cancel. Then I have 7x plus 3x, which is 10x. Then I bring down the 30. Now, here's the thing. And then I start the process all over again. If this polynomial had more than 3 terms, you'd bring all of them down instead of just one part. Bring the whole rest of it down, and I'm going to show you an example of that in a second. All right? But now we start all over again. And we go, okay, how many times does... Wow, where did that go? That was not what I wanted. How many times does x go into 10x? Again, if you weren't able to figure that out, that is 10x divided by x, which is positive 10. Multiply 10x minus 30 and subtract. The thing you'll forget is the subtract. Remainder is 0. x plus 10 is the answer. It goes in evenly. Okay? So again, that process is the same as regular division. Correct. No, there's no remainder. So no, there's nothing else after it. Then you'd write it up there the same way we did the other one.
So you put x plus 10 whenever the remainder is over x minus 3.
Correct. Okay. Now, I'm going to show you two problems, but we're only going to do one of them. This is the problem I want to show you. We're not going to do it, though, because I want us to be sure when you see a problem like this that you know what it means. Okay? Remember, negative powers are bad. That needs to go down. So in reality, what this is r squared plus 5r plus 7 over 1 minus r to the first. There, I wrote it. Okay, so in reality, this is just another division problem. There's one other issue with it. When I go to write it, this part's fine. It is in descending order. The powers go down from left to right. Okay? The divisor, that's not the case. The powers go up on the variable. I actually need to rewrite this. And put the r term first so that the powers go down. So if you run into a situation like this, make sure your dividend and divisors are in descending order, meaning the highest power on the variable comes first, and they just keep going down as you move to the right. This is the problem I want to work through with you. So you're going to see a problem like this in your homework. Just know how to rearrange it, and you do it just like the other one. Okay? For now, there's no other way to do this problem than long division. Okay? I'm not going to show you how to use synthetic division on something like this until we get back from Thanksgiving break. And the reason is because there's a number in front of the b. This forces us to do long division. Okay? So when I write it out, okay, it doesn't skip anything, so I don't have to put any zeros in. Okay. In this case, my first move is to see how many times 5b goes into 15b to the third. So if you weren't sure how to figure that out, you could just do the division, but it is 3b squared. Okay, go ahead and finish that problem. So, take a look here. This is where you want to bring everything else down. Don't just bring the negative 21b down. Bring all of it down. Yeah, I didn't. I got positive and then I subtracted.
I think I got it.
So you got to subtract. So you multiply it and then you subtract. Don't forget to subtract. So again, here's what happened. All right, we do the first one. I get 20b squared. I bring everything down. Now 20b squared divided by 5b is 4b. I multiply. That gives me 20b squared minus 16b. But by subtracting, I change both of these signs. Those cancel. This gives me negative and a positive, so it's negative 5b. Bring down the 6. 5b goes into negative 5b minus 1 time. Then I multiply. Negative 1 times 5b is negative 5b, times negative 4 is positive 4. Then I have to subtract, which changes both signs. So 6 minus 4 is 2. That's my remainder. It goes up here over the divisor. How many had that? Good.